Good morning, this is Amuj Kumar. Today I am going to teach you on the topic Molecular Orbital Theory, in short MOT. This topic is very much important in exams like IIT JEE, AIMS, NEET and other engineering level exam, also in international level chemistry Olympiad exam. So after this video, I am 100% sure that you will solve any type of questions from this topic, which is very much marks gaining for all of you in exams like NEET, JEE Mains, etc. Every year, at least one questions must ask from this topic, so you should understand how much important this topic is. So let's go into the presentation. Molecular orbital theory. According to MOT, a molecule is considered to be quite different from a constituent atoms. All electrons belonging to atom constitute a molecules are considered to be moving along entire molecule under the influence of all nuclei. As shown in this figure, two atomic orbital which is half filled, on combining they form a cloud of electrons as shown in this figure, new molecular orbital. But in valence bond theory, VBT, this form covalent bonds which in 2D representation is shown as given below. In other words, you can say that these atomic orbitals are monocentric, but in this new molecular orbital, these are called polycentric, or in valence bond theory you also call this polycentric. Just like in valence bond theory, in molecular orbital theory, it also makes use of atomic orbitals, in which atomic orbitals of one atoms overlap with the atomic orbitals of other atoms to form entirely a new orbitals, that is called molecular orbitals, where original atomic orbitals lose their original identity. मीन्स ये दो एटॉमिक ऑर्बिटल इस दोनों को कंबाइन करके एक नया मॉलिक्यूलर ऑर्बिटल फॉर्म कर देता है, जो कि अपने ओरिजिनल एटॉमिक ऑर्बिटल की आइडेंटिटी को लूज कर देता है और न्यू आइडेंटिटी गेन कर लेती है. ओके, दिस थ्योरी इज कंप्लीटली रिलाइड ऑन वेव मैकेनिकल अप्रोच. its behavior is very much similar to the waves. Molecular orbital formation is basically based on the linear combination of atomic orbitals. Here a linear combination of two atomic orbitals represented by psi A and psi B, where psi A and psi B are the amplitude of electron waves of atomic orbitals, psi A and psi B. On adding these electron waves, they are forming bonding molecular orbitals, or also we can say constructive interference type, which is represented by psi plus, and that of destructive interference psi minus, which is formed by subtracting psi A minus psi B. In this case, psi plus, energy of this psi plus is lower than either energy of psi A or energy of psi B. But in destructive type, energy of psi minus is greater than either of psi A or psi B. Now we will study how the molecular orbitals are formed. Here s orbital of a spherical type shape, another s orbital of a spherical type. On constructive overlap, they form this type of a structure, which is named as sigma 1s. On destructive overlap, they will form this type of structure. In this, there is one nodal plane which can be asked in any exam कि कैसे डिस्ट्रक्टिव इंटरफेरेंस में एक नोडल प्लेन का क्रिएशन होता है, which is named as sigma star 1s, which is less stable, and sigma 1s is more stable. because this form constructively and this form destructively. In case in PP overlap, we first will discuss sigma overlap. In this, two p orbitals combine and form this shape. Here in this, two nodal planes are present, one at this position and other at this position. Another possible combination of overlapping is positive side of psi 2pz and negative side of psi 2pz. They will combine and form this shape. Here in this case, in case of sigma star 2pz, three nodal planes are created. This question is very much important. जैसे कि एग्जाम में पूछा जा सकता है कि on destructive interference how many nodal planes are formed. This is very much important questions. So in this case, sigma star 2pz, three nodal planes are created, and if they will ask for showing, then this first one, this dotted line second one, and this dotted line third one. These three nodal planes are formed in this case. And in case of PP pi overlap, this plus magnitude amplitude combines and form this type of shape. Here in this pi 2py or pi 2px, anything you can say. Pi 2px, pi 2x combined with pi 2px, psi 2px combined with pi 2px or pi 2py, anything you can say. And similarly, in case of destructive one, in plus minus, these are just signs. You don't understand that these are plus or minus sign. ये बस simply एक sign है जो show कर रहा है electron amplitudes. So in this case, in case of psi star 2px, there are two nodal planes. This is very much important. ये आप मतलब कि एकदम याद कर लेना होगा कि in case of PP overlap, PP pi overlap, if both are plus minus, then there will be two nodal planes. This is very much important questions. Now we will discuss energy overlap diagram for molecular orbitals. Here in this diagram, this is so that 1s, these two combines for electrons less than 14 electrons and for electrons greater than 14 electrons. These two are similar in case of 1s, 2s and form sigma 1s and sigma star 1s. Similarly in this case, but in case of p orbital, there is slight variation in energy. If electron is less than 14 or less than equal to, then this is called abnormal order. Here in case sigma 2pz will come above, but in electrons greater than 14 electrons, sigma 2pz is in normal condition. So this is the case of normal order and this is the case of abnormal order. In some exam this question is also asked, so please remind this. And later in pi star orbitals, sigma star 2pz has a higher position. There is no variation in this, only variation in this. And one most important question, why this variation? Only one option is due to the mixing of 2s and 2p orbitals. This variation will be caused. Later on I will discuss one most important question on this topic, on this SP mixing, which is very much important, and this particular question is asked in international level Olympiad questions. So remind this question. Now moving next, for any species, bond order, formula for bond order will be half of number of electrons in bonding molecular orbitals minus number of electrons in anti-bonding molecular orbitals. This is general formula, and later on I will also discuss one most important formula, which you, after learning that formula, you will be able to solve question within 10 seconds. And in competitive exam like JEE NEET, JEE Mains NEET, they basically requires fast calculation. They do not require how you will form a main answer. They only focused on fast calculation. and you will, after this video, you will able to solve this question within 10 seconds, even within 5 seconds also. I am very much expertise in this, and I solve this type of questions of bond order within bond order, bond length within 5 to 10 seconds. And you are, and I think that you also will be expertise in this. Let's calculate H2 molecules. Bond order of bond order, simply apply the formula. Molecular orbital configuration will be sigma 1s2. Here this is arrangement of electrons in H2 molecules. Bond order half, 2 minus 0 1. Similarly, in case of helium He2, we write molecular orbital configuration and apply the formula. Here 0 bond order indicates that molecules does not exist in nature. Lithium Li2, we will similar. One most important point, they will also ask for magnetic, diamagnetic, paramagnetic type of nature. For this, you will use the formula mu equal to root under n plus 2, and you will calculate number of unpaired electron. Here in this case, lithium Li2 plus, there is no unpaired electron, means these are diamagnetic. This is shortcut, that if there is any unpaired electron, then that molecules may be, and in most of the condition that molecules is paramagnetic, and those who have unpaired electron, they are diamagnetic. Here in this case, there is no unpaired electron. Here 2 electrons that are fully filled. And one most important point, that filling of molecular orbital is based on of Bow principle, Pauli exclusion principles, this type. So in case of beryllium, bond order will be 0. So we calculate that using that formula. Boron, similar way, say Kk, here Kk represent sigma 1s2, sigma star 1s2, sigma 2s2 in a similar way. For carbon atom, there in similar way. Nitrogen, here in the, how will detect that whether this element is diamagnetic, paramagnetic? I will explain that. In this there is all electrons are paired electrons. There is no unpaired electrons, and this is diamagnetic. If there is unpaired electron, then the electron is paramagnetic. In this case, here you see there is one unpaired electron, so this is paramagnetic. In case of O2 minus, this is paramagnetic. There is one unpaired electron. Sorry, one for slight mistake. Here in this case, O2 minus, there is pi star 2 py. Here only one electrons are filled, because in there it total 17 electrons, and so there will be one electrons in pi star 2 py 1. Hence this element, hence this one is paramagnetic. Now in case of O2 2 minus, all electrons are paired, hence diamagnetic. Bond order half 10. Total bonding or bonding electron, non-bonding, total bond order will be 1. In case of fluorine, this will be diamagnetic. You can use similar formula. General trend for number of electrons having number of element having number of electron greater than 14. This trend will follow sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s, sigma 2 pz, pi 2 px, pi 2 have same energy levels. Pi star 2 px, pi star 2 py have same energy level, then sigma 2 pz. This is called normal order. And if n is less than 14, then for such as in case of n2, c2, b2, this trend will be followed. One shortcut tricks that I particularly mention in this video, that if you have very less time, then if any one of you says that calculate the bond order of C2 minus, then you simply use the formula for bond order n minus 8 by 2, where n is total number of electron. In carbon, total number of electron 6 into 2 plus 1 means total 13 electron. 13 minus 8 by 2 equal to 2.5. Within this formula, you can calculate within 2 seconds, within 5 seconds. For anyone says that calculate bond order of CO or BO. Here in case of BO, there will be total 14 electron minus 8 by 2. Total bond order will be 3. In case of NO plus, total bond order will be 3. Here in case of total electron will be 14 minus 8 by 2. Similarly, in case of Cn minus, total electron will be 14, carbon 6, nitrogen 7, 7 6 13 plus 1 14, okay, minus 8 divided by 2, which will be bond order for Cn minus will be 3. Similarly, in this case you can calculate bond order for all other molecules. If n will be greater than 14, then use this formula 20 minus n by 2. Suppose O2 minus, here in this case total number of electron will be 17, so bond order will be 20 minus 17 by 2, which will be 1.5. In case of O2 plus, bond order will be total number of electron will be 15, 8 to the 16 minus 1 15. So bond order will be 20 minus 15 by 2, 2.5. One of the most important question which I will discuss earlier, that this question may be asked in JEE type exams, or in this type of question is basically asked in Olympiad. So I basically try to add this particular question so that you will be we will understand the concept very clearly. Question is says that if mixing of orbital is not considered, okay, then what will be the bond order of boron? You can say any other molecules. I simply take boron. We will case two case. If mixing of sp is not allowed, then what will be configuration of B2? B2 configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2. Here in this case bond order will be 1, but nature will be dimagnetic, okay, because there is no unpaired electron. If mixing is considered, and now mixing is considered, then configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then pi 2 px1, 1 electron will be to those both. Here in this case bond order is also same, that is 1, but nature is paramagnetic type, okay. In case both of them have same bond order, but same bond order does not mean that bond energy will also be same. This type of question may be asked in multiple select question, MSQ type questions in exam like JEE Advanced or in other Olympiads, international level Olympiads. So understand, here in this case pi 2 px1, pi 2, here we will share 2 electron in this way, and in this case sigma, both electron will goes to sigma 2pz if mixing of sp is not allowed, okay. If mixing is allowed, then electron will be shared in this way, and in this case nature is paramagnetic, in this case nature is dimagnetic. One other important question that even in NEET this question is asked, that what will be bond order of CO plus? It follows abnormal trend. Its configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, but sigma star 2s2 in this case due to higher energy it lose electrons from anti-bonding molecular orbital, means it lose energy from sigma star 2s1, and other pi 2 px, pi 2 y, they share to 2 electron, and sigma 2 p 2 electron, but in sigma star 2s1 they share only 1 electron, and bond order in this case will be 3.5. This is also a very important question. You should remind you this question. Now, where is the application of bond order? Why you calculate bond order? Bond order. If any question, if anyone in any question, if you ask what will be a stability of this such compound, such as CO plus, CO, CO3 2 minus, then how you will calculate? You will simply calculate bond order of a particular CO, CO plus and CO3 2 minus. For CO3 2 minus I will discuss very important tricks after very soon. So please wait for that. Till that I will discuss this application of bond order. Bond order directly proportional to stability and bond order inversely proportional to bond length. If you have to compare bond length of these three, then simply calculate bond order, and one which have less bond order will have higher bond length, one which have higher lower bond order will have higher bond length, and similarly inverse relation is followed. But in case of stability, direct proportion is followed, bond order directly proportional to stability. You will calculate whatever type, you will calculate bond order and compare stability, bond length, bond energy, similar. Now one most important, bond order in compound showing resonating structure. In general, formula for this type is calculate the total number of bonds, number of total bonds upon total number of resonating structure. This is formula for bond order. Suppose you have to ask for formula for carbonate ion, CO3 2 minus. Here in this case C double bond O, we will create all the resonating structure of this compound. Hence there are total 3 resonating structure and total number of bonds. Here 2 bonds, 1 bonds, 1 bond, total 4 bonds. Hence bond order will be 4 by 3, 1.33. This is general way of calculation. Okay. Now sulfate ion. We will first create all the possible resonating structure, which I will create all the possible combinations, and total number of for calculating bond orders, then total of resonating structure 6 and total number of bonds. And so here in this case sulfate, total number of bond will be 6, 2O, here 2 bond, 1, 1, total 6 bond, and total resonating, this only this 4 resonating structure, all these 2 are similarity, hence their total number of resonating structure in case of sulfate ion will be 4, hence bond order will be 1.5. Now very important, how to calculate shortcut tricks for oxygen containing anion, such as sulfate, carbonate, phosphate, chlorate, and any other type, such type of. In this case, simply we will have to suppose we will explain by this example. Here in this oxygen, which valency 2 minus formal charge 2 and total of oxygen atom 3. Hence bond order will be 2 minus 2 by 3, 4 by 3, 1.33, and just C, same bond order. This is very shortcut tricks, and if you have to draw resonating structure, this is very much time consuming, and for this type of questions is asked in every exams of NEET, JEE Mains. So you should have to focus more on this shortcuts, because you have to do this question in very much less time, within 10 seconds, 15 seconds, 20 seconds. So you will basically, first you should also have to know how to calculate bond order by this general process and by this shortcut tricks also. Here in case of sulfate ion, bond order will be oxygen valency 2 minus formal charge 2 divided by total of oxygen atom 4. 2 minus 2 by 4, 6 by 4. Hence bond order will be 1.5. For phosphate ion, similar case, bond order 2 minus 3 by 4, 5 by 4, 1.2. Very much important. Okay. This is very much important. This question is asked in most of the exams. You should remember by heart. Now bond, you should also have to ask a bond order of benzene type organic compound. You will calculate sigma, total sigma bond, total pi bond, and divide this sigma by pi. Okay. So with this I am ending this lecture, and in next video I will upload various type of questions which is asked in different exams, and I will sure that you will solve all those type of questions within 10 to 20 seconds by learning all these concepts. Thank you and have a nice day.